Notes 11, chain rule. You guys ready? So we've done derivatives of sine x and we've done derivatives of x squared minus 4. But how do we take a derivative like something like sine of x squared minus 4? And that's what we're going to learn right now. There's a composite function, right? So look, I have a function here, 6x minus 10, and you can factor out a 2, and that will turn into 3x minus 5. And this is just to prove the chain rule. So we know, so let me go ahead and just start writing here. So I'm going to go slow. We know that this derivative is just 6. Yes or no? Okay. So notice that we can rewrite this as y equals 2u, where u equals 3x minus 5. So this is what the chain rule really is, guys. Notice that when I take the derivative of y here, that's a u. So I'm really doing this, dy du. And if I take the derivative of y with respect to u, that's just going to be just 2. Do you guys notice that? I didn't do anything crazy. Have I done anything crazy yet? No. Notice it says a u. So if I'm taking the derivative of this guy, I'm going to write du over dx. That means I'm taking the derivative of u with respect to x. And notice that that is just 3. Remember, this means, and I guess I should have written it as dy dx. Remember, this y prime means dy dx equals 6. So chain rule really is this. So dy dx equals dy du times du dx. This dy du is like saying derivative of the outside, leave the inside alone. And then this du dx is like saying derivative of the inside. Notice that the du's cancel, and you just get dy dx. Remember, the derivative was 6 on this expression, right? So let's see if this works. Dy du, 2, times du dx, 3. Oh, look, you get the same answer, guys. See? So it works. That's called the chain rule. What is chain rule? It's really this guy right here that I'm circling or putting in rectangle. That's the chain rule right there. Derivative of the outside, leave the inside alone, times derivative of the inside. Don't worry, we're going to do a whole bunch of them. So let's go to the next one. See, we're just doing this again. The polynomial, and this is my function, and then they turn it into this. Just in case, guys, 3x squared plus 1 squared. I hope everyone knows that when you expanded it, you get that. 3x squared times 3x squared, 9x to the 4th. 3x squared times 1, that's 3x squared, but you got to have 2 of them. So 6x squared, 1 times 1 is 1. See? It's the same. So real quick, just to verify, dy dx. What's the derivative of 9x to the 4th? Yeah, 36x cubed plus, what's the derivative of 6x squared? 12x. There it is. That's it. So that's what I'm trying to verify to see if I get that. Of course, we're going to get that, right? So here we go. I'm going to write, they're going to call this guy the letter u. So I'm going to write y equals u squared, where u is equal to 3x squared plus 1. And I'm going to go slow. When I take the derivative of this guy, dy du, because I'm taking it with respect to u, you just get 2u. Yes or no? When I take the derivative of this guy, the u, du dx. The derivative of this guy is just 6x. Chav, we don't get that 36x cubed plus 12x. Let's see. Dy du times du dx equals 2. And instead of writing a u, I'm going to write it in terms of x. 3x squared plus 1 times 6x. Are we still okay, guys? I'm just doing algebra. 2 times 3x squared, 6x squared, 2 times 1, 2. And I still got to multiply that sucker by 6x. 36x cubed, that's a cubed, plus 12x. Did I get the same thing? Yes. So would you do chain rule for something like this? Probably not. You'd probably just go right into just getting a polynomial, just taking the derivative. But you can see that it works. And that's so what do M&Ms have anything to do with this? I'm not going to give you guys M&Ms, and I'm not going to say something like try and chew the outside candy first, and then the chocolate, and then the peanut. But I don't know. Maybe I need to think of a new way to do chain rule besides that with candy. You work your way outside in, guys. You work your way from the outside to the inside. Cool? That's all there is to know. That's chain rule. So here it is. And it says rule 8. That's because it's coming from a Demena textbook. We're not using our textbooks. We're just using these guided notes. Here it is. This is a composite function, guys. This is what it means. See? Derivative of the outside. That's your outside here. Leave the inside alone. Times derivative of the inside. Der of inside. That's all it means. Derivative of the outside. Leave the inside alone. Times derivative of the inside. See? Cool or not cool? Okay, so check it out. So an object moves along the x-axis, so its position at any time t greater than or equal to 0 is given by x of t. Find the velocity of the object as a function of t. So how do I find velocity from position? Take a what? Yeah, how do I find velocity from position? From a position graph. How do I find velocity, guys? Yeah, okay, well, but if I have position on my x-axis and if I have time on my x-axis, yeah, the slope, instantaneous rate of change, right? So how do I find an instantaneous rate of change? Maybe I'm not asking it right. They give you a position function. So remember, this is just going to tell you your position at any time t. Did they give me units here? If it had units, it would be in meters or feet or something like that. Okay, that's if I want the average velocity. How do I find the instantaneous velocity? Take a derivative. Guys, we're doing cal. You just take a derivative. We're doing instantaneous rate of change. So take a derivative of position. That will give you velocity. What's the derivative of velocity? Acceleration. What's the derivative of acceleration? Do we know? It's called a jerk. I don't know. No, for reals, it is. That's why you see some t-shirts that say you're the third derivative of position. They're calling them a jerk. So the derivative of acceleration is jerk. No? You've never seen it? Go to Google and you'll find it. All right. Or put like math puns or something. All right, here we go. So the cosine is considered outside, and it always has an argument. So this is probably not the very best question to do this. Okay, here we go. What is the derivative of cosine? Negative sign. Leave the argument alone. You got to leave the argument alone anyways. You're not done with the derivative. That is not cosine of x or cosine of t. It's cosine of t squared plus 1. So now you got to take the derivative of the inside. What's the derivative of t squared? 2t. There it is. So if we're rewriting it nice and pretty, negative 2t sine of t squared plus 1. Done. That's it. Are we okay? Don't worry, we're going to do more. See, we tell you here how you say it. Take the derivative of the outside, leave the inside alone, take the derivative of the inside. All right, outside, inside rule. Let's try example 3. Okay, so what was example 3? Oh, we just did it with, okay. I'm going to put awkward emoji because we did it with that route. Okay, here we go. Example 4. We're going to go slow. I'm going to write d dx of sine of x squared plus x. So if it was just the derivative of sine x, you would just say cosine x. But it's not the derivative of sine x, it's the derivative of sine x squared plus x. So what's the derivative of sine? Cosine. Leave the argument alone. You have to for these anyways. And then I say the derivative of the inside. What's the derivative of x squared? 2x. What's the derivative of x? There it is. Done. That's it. In case you're wondering, Chop, have we always done it? You always have. You just didn't know it. Look, derivative of sine x. The derivative of sine x, cosine x, times the derivative of the inside times 1. The derivative of x is 1, but you usually don't show it. See? Cool or not cool? All right, here we go. We got our first 3-link chain. Don't worry, we're going to go slow. You work your way outside towards the in. So I'm going to write g prime. What is the derivative of tan? Not negative. Secant squared. Yeah, guys, you got to practice. Leave the inside alone. Yeah, some of you guys haven't been practicing. You got to practice, guys. That's what I'm telling you, to do all those circuits and those questions. It should be by now, should be pretty close to automatic. At least the secant and the tangent. Because you've done enough of problems that it should be pretty close. All right, we're not done yet. Then I do the derivative of this inside. The derivative of 5 is 0. What's the derivative of negative sine? Negative cosine. Keep the argument. And now I got to do the derivative of that inside. What's the derivative of 2t? 2. All of it is a product. So maybe rewrite it nice and pretty. Of course, remember, this is the argument of secant, so you can't do anything about that. So it's going to look like this. Negative 2 cosine 2t secant squared 5 minus sine 2t. Please don't multiply the argument. The argument says itself. Side note. Some of you guys have done this. Sine x times x, and you will say that that is sine x squared. It is not. Do not do that. This is the argument. This is sine x times x. When I say argument, I mean like sine theta, f of x. See that f? That's the argument, your expression here. So you move that x to the front. So sine x times x is x sine x, not sine x squared. You don't do that. So don't do that, please. Because of this. Negative cosine 2t times 2 is negative 2 cosine 2t. Ask me, miss. Ask me. You could put negative 2 secant squared 5 minus sine 2t times cosine 2t. Just don't make it, okay, something that I saw on a circuit. All right, real quick, guys, real quick. Something that I saw on a circuit. Why can I not do this? What does that look like to you? What does this look like? Doesn't it look like you're subtracting? Yeah, if you do that, it's wrong automatically. Parentheses will save you. You usually want to have the constant in the front. So you put it in the front. You don't have to have the cosine in the front. I just like to go in alphabetical order. The c's comes before s. So I go cosine 2t, secant squared 5 minus sine 2t. I always assume that math textbooks are doing that because I always see that there's some order. But you could have said the secant squared first. That's why when you take the derivative of secant x, you say secant x tan x and not tan x secant x. Tan x secant x would have been just fine, but I just think that there's an order and they probably just do it alphabetical. Did I answer your question? Yeah. All right, here we go. Let's go real slow. I'm going to go really slow, guys. Find the slope of the line tangent to the curve, y equals sine of the fifth power x at the point where x equals pi over 3. Before I even start, it's a sign that is being raised to the fifth power. Come on, Travis, focus this. So it's a sign that is being raised to the fifth power. Do we see that, guys? So I'm going to rewrite it because we're rookies. Because we're rookies, I'm going to rewrite it like this. I guess let me put a parenthesis on the... Well, I guess I don't need to. We're rookies, so I'm going to rewrite it like this. So what is on the outside? Well, nothing, just 1. What's on the inside? The sine x. I'm going to put, this is similar to y equals x to the 5th. Similar. What is the derivative of x to the 5th? Okay, perfect. That's what you're going to do. But leave the inside alone. You ready for the chain rule? I'm going to go real slow. dy dx, you can also say y prime, equals, so what's the derivative? 5, open parenthesis, sine x, close it to what power? 4, awesome, times, we're not done, times derivative of the inside. What's the derivative of sine x? Cosine x, perfect. Here it is. Let's just go ahead and rewrite it. I'm going to go ahead and do it the alphabetical way. So I'm going to put the cosine x first, and then I'll put this one next. Sine of the 4th power x. There it is, nice and pretty. You don't have to put the cosine x first. You could have said sine of the 4th. Maybe put that one in the beginning because it has the higher power. Doesn't matter. Or I'll put both here. It does not matter. How do we feel? Okay, so check it out. Relax. You're not going to do quotient rule. If you're thinking that, you could. You see how you just have a constant in the numerator, guys? Make life easy for yourself. ddx, I haven't taken a derivative, that's why I'm writing ddx. If I bring this 1 minus 2x up, what's my new power? What's my new exponent? -3. Good. Whoever said that. Was it you, Martinez? Isn't that cool? We haven't taken the derivative yet, guys. We just did algebra. I just moved the power up. Cool or not? All right, here we go. I'm taking a derivative. I got to do chain rule. What do I do with that -3? What do I do with it? Bring it down. Do I do anything with the inside? No, leave it alone. Close it. What power? -4. Am I done? No. What do I multiply by? Which is? Perfect. Make it pretty. What's negative times a negative? So 6 over 1 minus 2x to the 4th power. Negative times a negative is a positive. Well, when I move it, if they present it to you with a positive exponent, you probably want to give it in the positive exponent. Yes, you could have left it though. All right, here we go, guys. Let's see if you guys can get these questions correct. You guys give number 1 a shot. If we have a volunteer that wants to come up and do it for us, even better. What's the derivative of tan? Secant squared. Leave the inside alone. Am I done? Times what? Which is? So I'm looking for 4 secant squared of 4x. Is it in there? All right. Give number 2 a shot. Rewrite it. Rewrite it so you don't get it. Once you become a pro, you can just go right into it. But rewrite it, guys. There it is rewritten. I just rewrote it. I haven't even taken the derivative yet. Y prime, I'll write over here. Y prime equals, I'm going to bring that 2 down. Giant parenthesis. Leave the inside alone. Cosine of x cubed plus x squared, close, to the power of 1. You don't have to put the power of 1. Am I done? No, times the derivative of the inside. What's the derivative of cosine? Negative sign. Put parentheses because then it's going to look like you're subtracting. Negative sine of x cubed plus x squared, close. I guess you can close this one. Am I done? Am I done? Or no, times the derivative of that inside. What's the derivative of x cubed? What's the derivative of x squared? There it is. All that is a product. So let's see. What are we going to write first? Y prime equals, I see a negative, so I'm going to put the negative in the front, 2. And then I'm going to put the 3x squared plus 2x first. And then I'm just going to do the cosine and sine. Cosine of x cubed plus x squared, sine of x cubed plus x squared. They could have used a property, a half angle property or a double angle property, depending on how you look at it, but they didn't. So the answer is, yeah. This is getting easier, guys. Okay, we're just going to practice a whole bunch of practice. The very first ones are not chain rules. I see A, B, C, D. Chain rule doesn't come until letter E, but that's fine. It says, what does it say? Suppose that the function f and g and their derivatives have the following values at x equal 2 and 3. Evaluate the derivative with respect to x of the following combination of the given value of x. Okay, so I'm taking the derivative of this. I'm going to write d dx of 2f of x is nothing more than 2f prime of x. 2f prime at 2 is nothing more than 2 times, what's f prime of 2? 1/3. So 2 times 1/3 is going to be 2/3. And I'll go slow. Maybe I went a little fast there. Okay. Are you ready for the next one, guys? All right, letter B. I'm just taking the derivative of that. So d dx, try to get better with notation. F of x plus g of x is nothing more than f prime of x plus g prime of x. On the next line, I want the derivative of what value? At 3. On the next line, I'm going to write f prime of 3 plus g prime of 3. So f prime of 3 is 2 pi plus g prime of 3 is 5. Oh, why did it come out like that? 5. There it is, 2 pi plus 5. Anything crazy so far, guys? Okay. That little, I don't know, little rectangle there should have been a little dot, but for whatever reason, the formatting didn't want to do it. Maybe I need to update my software or something. All right, d dx of f of x, g of x. What rule do I got to use? Product first times derivative of the second plus second derivative of the first. So I'm going to come over here and I'm just going to start plugging in 3. F of 3, g prime of 3 plus g of 3, f prime of 3. So f of 3 is, now I'm just looking at the table. F of 3 is 3, and let me know because I make mistakes all the time. G prime of 3 is 5. G of 3 is negative 4. And f prime of 3 is 2 pi. So let's see what that final answer is. 15 minus 8 pi. And then let me know if I'm wrong. We're okay so far, guys? What rule do I need for letter D? What rule? Quotient. D dx f of x over g of x. I'll do it in a different color so we don't get it mixed up with the one on the left. What is quotient rule? Yeah, low D high, bottom, times derivative of the top, low D high, minus what? High D low. Top times derivative of the bottom. Bottom times derivative of the top minus top times derivative of the bottom. And all this is over. Yeah, bottom squared. Guys, you got to practice. You got to practice, guys. So don't just go through the motions. Make sure to take care of business and make sure you have enough practice. That's the only way we're going to get better, right? How do you get better at basketball? By practicing. How do you get better at anything? You got to practice. All right, here we go. I'm going to go ahead and plug in the 2. So I'm going to go g of 2, f prime of 2. If you're running out of space, you can just, you know what, no, I already started. F of 2, g prime of 2 over g of 2 squared. All right, let's see. G of 2. G of 2 is 2. F prime of 2. F prime of 2 is 1/3 minus f of 2, 8. And g prime of 2, -3. All over g of 2, so 2 squared. Let's see if I can do that really quick. I'm running out of space, but I think I can still fit it. 2/3 plus 8, 16, 24 over 4. I'm going to go ahead and multiply that 24 by 3, guys, because I don't want to leave it like that. 2/3 plus 25, 25, 25, so 72 over 3 over 4. 72 plus 2, 74. So keep change flip. So I have 74 over 12, which reduces. I'm not going to type it in my calculator. It's right here. Or was it 74 over 12? 37 over 6. I guess I could have just thought about it and we could have gotten an answer. Awkward. Okay. All right. Finally, we get one with that chain rule. You guys ready? Letter E. I'm going to go slow. D, I know that. No, Yanni, that's a demerit. You're funny, miss. All right. Derivative of the outside. So put f prime. Leave the inside alone. And now what? Times the derivative of the inside, g prime of x. There it is. Now what am I going to plug in for x? 2. So here you go. F prime g of 2 times g prime of 2. What was g of 2? I come back to my table. G of 2 was 2. You're right. G of 2 is 2. So this is going to look like f prime of 2 times g prime of 2. F prime, I should have changed the table up because I don't like that it's the same number. F prime of 2 is 1/3. And then g prime of 2 is -3. So it looks like we just get -1. All right, for those that have to go, let me just do one more, and then I think we'll be clear. The rest are just tougher chain rules, but at least have one more, and then we'll call it a day for you guys. All right, ready? So one more chain rule. Let's rewrite this. DDX. Oh, let me change the color. I'm going to change the color to green. Do you guys like green? DDX. Ooh, I like green. Of square root of f of x is the same thing as saying d dx of f of x to the power 1/2. Do you guys see that? All right. Tell me, what do I do? What do I bring to the front? 1/2. Leave the inside alone. What power now? I heard someone say negative. You're right. Negative what? Negative 1/2. Am I done? Times what? Derivative of the inside, f prime of x. Let's fix it. F prime of x over 2 square root of f of x. We're done with calculus now. We're just doing algebra. So here we go. Ready? What happened, Konduro? Tell me. I put the 1/2 in the front. I left the inside alone. I subtracted 1, then negative 1/2, times the derivative of the inside. That's my inside, f of x, derivative of the inside. Okay. All right, here we go. F prime of 2 over 2 square root of f of 2. So f prime of 2. So go to your table. What's f prime of 2? 1/3 over 2 square root. What was f of 2? 8. Let's see if we can make this prettier. 1/3 over 4 times 2 is 8. The square root of 4 is 2. 2 times 2 is 4. So 4 square root of 2. We still okay? This turns to 1 over, what's 4 times 3? 12 square root of 2. Let's rationalize it. So square root of 2 over 12 times 2 is 24. There it is, guys. How do we feel? Do we feel okay? Are they going to call you guys out, or do you guys just have to go, or what? At 10:45? Okay, so we still got time. Let's go to the next page. Don't worry, we got 2 more. Look, you guys are already done. Looks like we're going to finish. Do we have to do quotient rule for letter G? No, guys. Pick it up like this. Let's see. D dx of 1 over... I'm going to write it like this, guys. G of x squared like that is d dx gx to the negative 2 like that. Is everyone okay with what I just did? Just algebra, guys. Just algebra. Here we go. Equals. Tell me. Dime, what do I do? Negative 2, drop it. Drop it like it's hot. Okay, that was dumb. I won't say it again. Parentheses. Do I do anything with the g of x? Leave it alone. What's my new power? Negative 3. Am I done? Times what? Derivative of the inside. Let's make it pretty. Negative 2g prime of x over g of x to the 3rd power. I just did algebra. That negative 3 made it positive. I'm going to plug in. Negative 2 g prime of 3 over g of 3 cubed. Man, I should have put the table over here. All right. What is g prime of 3? Can someone hook me up? 5. And then what is g of 3? What is it? Negative 4. All right, let's see what this is. Negative divided by negative is a positive, so I have 10 over 64, which reduces to 5 over 32. Yay. All right, last one. This one you're probably, oh, sorry, for those of you that weren't done yet. This is probably going to take up most of this space, so try to write small because there's a lot going on in there. So let's rewrite it. D dx, giant parenthesis. Yeah, let's rewrite it already. Uh, another parenthesis, f of x close it squared plus g of x close it squared, close it 1/2 close it. The f of x squared plus g of x squared is inside the parenthesis of the 1/2. Are we okay? Okay, here we go. Bring the half to the front. 1/2, giant parenthesis, f of x squared plus g of x squared, close it to what power? Negative 1/2. Am I done? No. Then I got to take the derivative of this guy right here. What's the derivative of f of x squared? Perfect. 2 f of x. Just 2 f of x? Nope, not plus. But f of x is missing something. No, it's not. It's missing a prime, but not on this one. I got to go times. No, you're right. Say it, miss. Say it loud and proud. Go multiply by f prime. You got to multiply by f prime, guys. Chain rule. Look, if you just do that f of x squared on the side, look, guys, if you do chain rule on that, d dx, you bring the 2 to the front, leave the inside alone, power 1 times f prime of x. Do you guys see that? Yes or no? Okay. I took out a little bit, but not much. All right, there it is. I'm not done yet. Plus, what's the derivative of gx to the power 2? Hopefully we'll get that one right now. 2 gx times g prime of x. That's the chain rule, guys. That's the chain rule. 2 g of x, leave the inside alone, times the derivative of the inside, g prime of x. Yay or nay? All right, here we go. Make it pretty. 2 f of x, f prime of x, plus 2 g of x, g prime of x, over 2 square root of f of x squared plus g of x squared. Is there anything I can cancel out? The what? The 2's. You can factor out a 2, and that 2 cancels out with that 2. Do you guys see that? All right. We finally are here to get the answer here. F of 2, f prime of 2, g of 2, g prime of 2, over square root of f of 2 squared plus g of 2 squared. Look at the table. What is f of 2? 8. What is f prime of 2? 1/3. Plus, what is g of 2? Negative 2. Just 2. What is g prime of 2? Negative 3. All over the square root. Let's see, f of 2 was 8. 8 squared plus g of 2 was 2. 2 squared. These are all correct numbers, right? All right, let's see what that is, guys. Now we're done with calculus. We're just doing arithmetic now. 8/3 minus 6 over 64 plus 4. So 6 times 3, 6, 12, 18. 8/3 minus 18 over 3 over square root of 68. So negative 10 over 3 over square root of 68. Does the square root of 68 simplify, guys? Yeah, let's do that. If it does, here's how we do it. I'm going to use the calculator to help me out here. I'm going to go to the y1. I'm just going to put 68 divided by x. Oh, you got it? 4 square root of 17? Yes, it is. You're fast, miss. Or maybe I'm slow. 4 times 17. So the square root of 4 is 2. So negative 10 over 3 over 2 square root of 17. So keep change flip. Negative 10 over 6 square root of 17 times square root of 17 over square root of 17. 10 square root of 17 over, what's 6 times 17? 6 times 17. 102. Oh, you're fast. 102. All right. Simplify this. 10 over 102. That's 5 square root of 17 over 52. There. Done. 51. And yes, it's negative. Unless I made a mistake. 17 doesn't simplify. The even numbers, 10 and 102. 5 over 51. All right, guys. Now all it is just practice. So we got chain rule practice on delta. And then we'll do a circuit tomorrow. And then make sure to take care of your UH quizzes. I've been putting them on Canvas. I can't remember. Quiz 6, 7, and 8. We have 2 new ones. Quiz 7, quiz 8. Yes. Yes, but you can probably finish it today because it says ETA 30 minutes. And that's exactly how much time. Actually, we got more than that.